Welcome to the Mathematics in my channel. In this video we are going to solve another interesting integral from 0 to infinity x to the 5 over 5 to the x minus 1 dx. Okay, if you want you can generalize this integral by taking n instead of 5. However, in this video I am going to evaluate this integral. So here we have 5 raised to the x. So we know if we have a to the x, we know this is equal to e to the x times natural log of a. Okay, then we can write our integral is equal to integral from 0 to infinity here x to the 5 power over 5 to the x. So instead of 5 to the x we can write e to the x times natural log of 5 minus 1 dx. Okay, then I am going to take a substitution. So we can take u is equal to here x times natural log of 5. So x times natural log of 5. Now differentiate. So du is equal to natural log of 5 is a constant. So here dx. Well, then we know limit also 0 to infinity. So here we can write now 0 to infinity. Here x to the 5 power. So x we know u over natural log of 5. So u raised to the 5 power over natural log of 5 raised to the 5 power over here e to the u minus 1 dx. We know du over natural log of 5. Okay, then here we have natural log of 5 raised to the 5 power, here natural log of 5. So we know constant, so we can write outside of the integral sign natural log of 5 raised to the 6 power, then here 0 to infinity. Now here we have u to the 5th power times here e to the u minus 1. So I am going to write 1 over e to the u minus 1 du. Okay, now instead of 1 over e to the u minus 1 we can use our infinite series. So we can write this is equal to 1 over natural log of 5 raised to the 6th power integral from 0 to infinity u to the 5 power. Here 1 over e to the u minus 1 we know infinite sum, infinite series 1 to infinity e to the minus nu du. Okay, then we can switch the integral sign and sigma notation. So we can write 1 over natural log of 5 raised to the 6th power. Here n is equal 1 to infinity integral from 0 to infinity. Here we have now u to the 5th power e to the minus nu du. Okay, now this integral is familiar with us because we know about gamma function. We know the definition of gamma function. Gamma of n is equal to 0 to infinity x to the n minus 1 times e to the minus x dx. But here in gamma function we have the constant of x, coefficient of x we know minus 1, but here we have e to the minus n. So if you are familiar with gamma function you can write the answer immediately, but further understand I am going to take a substitution. So I am going to take nu is equal to t, nu is equal to t, then differentiate. So n times du is equal to dt. So we can write our integral is equal to 1 over natural log of 5 raised to the 6th power infinite sum n is equal 1 to infinity, then integral limit also 0 to infinity. Here u to the 5th power. So u we know t over n. So t raised to the 5 power over n raised to the 5 power times e to the minus x. So we know e to the minus nu. So nu we know t, so e to the minus t, then du we know dt over n. Okay, then we can write 1 over natural log of 5 raised to the 6 power sum of 1 to infinity, here n 1 over n to the 5 power, here 1 over n, so we can write 1 over n raised to the 6 power, integral from 0 to infinity, here t to the 5 power, so I am going to write here n minus 1, so t to the 6 minus 1, e to the minus t, t, t. Okay, then here 1 over natural log of 5 raised to the 6 power, and we know okay, I am going to write again here 1 over n to the 6 power, and this integral is definitely we know gamma function, so gamma of 6, then gamma of 6 we know 5 factorial, so here 5 factorial over natural log of 5 raised to the 6 power times this infinite series, we know the definition of zeta function, so we know this is equal to zeta of 6, and we can write 5 factorial over natural log of 5 raised to the 6 power, zeta of 6 we know 5 raised to the 6 power over 945. So if you want, still you can simplify. Okay, this is the answer. If you like this video, please subscribe this channel. Thank you for watching.